Hello, my name is Sofiya Manko and I'm a student of 11th grade of Lviv Physics and Mathematics Lyceum at Ivan Franko Lviv National University in Ukraine. This year I have won the second place at the all-Ukrainian stage of competition Defense Scientific Works, and my work is called Morley's Theorem, New Proofs, Applications and Generalizations. I became interested in this topic mostly because of its aesthetic appearance, and you can see the theorem in this red section. And it can be formulated in such way. The points of intersection of adjacent trisectors of an arbitrary triangle can form an internal equatorial triangle. Morley's theorem isn't studied in the school curriculum in Ukraine because of its complex proofs. So it became an impetus for me, and my first goal was to prove this theorem using the material from geometry which was familiar to me. And later I proved this theorem in a completely new way, which was based on the law of sines, different trigonometrical identities, various properties of triangles. And later, I also decided to examine the Morley triangle itself, and I found and calculated all its elements. Then I discovered the possibility of proving the generalization of Morley's theorem, because I asked myself, is the division of an angle in the ratio 1, 1, 1 can be the only one way to form an equatorial triangle? And after that, using the method of coordinates, analytic geometry, I proved the new theorem 1. And this theorem requires the only one angle beta to be known, and then you can find a pair of angles alpha and gamma, so that you can form an equatorial triangle. For this theorem, I also created a program in Python which can find pairs of alpha and gamma angles according to the fixed value of beta angle. And also for this program I add a graphic visualization in the form of graphs, and these graphs you also can see here. And after this program, I also discovered a possibility of proving a generalization of theorem 1, and then I formulated theorem 2, and this theorem 2 you can also see here. And this theorem can prove the fact that if two angles of an equatorial triangle are divided in the ratio 1k1, then the third one must be also divided in the ratio 1k1, so that you can form an internal equatorial triangle. And in the end of my research, I also consider an application of Morley's theorem, and showed an interesting method of constructing trisectors, which are extremely important in the problems which can be solved using this Morley's theorem. So thank you for your attention. Goodbye.